Everything that we've done so far has led us up to the point where we've reached the topic of the unit circle. Many of you hear about the unit circle and hear very negative things about memorizing it. When you go to calculus, the calculus curriculum does demand that you have these key trigonometry pieces of information memorized, simply because sitting down and figuring out what they are without a calculator is kind of time consuming. So if we consider building the unit circle, I don't just like to give the unit circle and say, here, memorize it without explaining to you why it's important and where it comes from. So if we remember the equation of a circle, this is the unit circle, the most basic of circles. And if we notice that it's already graphed for us, so I'm going to grab a highlighter, and I'm going to ask you to take a look at the center, which is the origin, and recognize that each of the radii in this situation has a length of 1. So that's something that's very important to remember about the unit circle, that the radius is 1. And that's going to impact the remaining part of our work. The unit circle is merely a graphic organizer. A lot of people tend to think that it does something more magical than that. It really is just an organizer that allows us to evaluate these trig functions at many angles in the 4 quadrants. And again, as I mentioned earlier, we use these a lot in calculus. So what we do is we take the 360 degrees in a circle and we subdivide it. And we subdivide this, and the first way we subdivide it is into intervals of 30 degrees. So here we would have 30 degrees, 60 degrees, 90, 120, 150, 180, and we can keep going on, 210, 240, 270, 300, 360, oops, I'm sorry, 330, pardon me. And back to the original starting point of 360. Notice that we've also done this in radians, so we can remember these in radians pretty easily by thinking pi over 6, 2 pi over 6, 3 pi over 6, and then reducing them. So 2 pi over 6 reduces to pi over 3, or 1/3 pi. 3 pi over 6 reduces to 1/2 pi, and so forth. 4 pi over 6, 5 pi over 6, 6 pi over 6, and then 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, and so forth. And you can keep going around the unit circle until you get back to 12 pi over 6, which is 2 pi. So there's a really nice way to remember your radian values for multiples of 30. So now once we put them all together, and you get your unit circle intervals, where you have 30 degrees, 45 degrees, 60 degrees, from, and I'm going to highlight this here. I know you guys think I like my highlighter bit here. So this would be 30 degrees, 45 degrees, and 60 degrees from here. If you think about it, we talked about reference angles. This would also be 30 degrees, 45 degrees, and 60 degrees from 180. So all of these 30, 45, 60 intervals exist in the other quadrants. They just differ by a sign change, depending on positive, negative in that quadrant. Now, applying more information to the unit circle, I mean, that's all fine and wonderful, and subdividing it really helps us learn our conversions from degrees to radians and back and forth. But what's also going to help us here are the trigonometric ratios of these special angles. So the reason that we reviewed the special triangles is to get those back into your brain, because developing the unit circle uses those quite a bit. And I'm just reminding you here what the different rules are. If you recall that the unit circle has a radius of 1, we can find all the other sides, the missing sides, if you will. So let's do the 45, 45, 90. We would say 1 divided by the square root of 2. And I'm going to rationalize that because on the unit circle, we get everything rationalized. So each one of these legs is going to be the square root of 2 over 2 for the 45, 45, 90. Now for the 30, 60, 90, they're going to be related because they both have a hypotenuse of 1, but they're just going to be flipped. So let's take this one for example. If we know that 1 is the hypotenuse, that's 2 times the short side, which makes the short side 1/2. And then the median side is the short side times the square root of 3, which is 1/2 times the square root of 3, or square root of 3 over 2. So across from the 30 will be 1/2, and across or opposite the 60 will be the square root of 3 over 2. Now you're probably wondering, well, does this have anything to do with the unit circle? Well, when we build the unit circle, those 60, 45, and 30-degree intervals are going to be crucial because we're going to lay these special right triangles right on the unit circle. If you look here on the left, what we're doing is, with this yellow highlighted triangle that I'm sketching, this one is going to be a 60. And I'm going to draw that in there just a little nicer. This one's going to be a 60. So if you recall from the previous slide, this was 1. Opposite from the 60 was the square root of 3 over 2, and 1/2. So this gives us our x coordinate and our y coordinate. X is 1/2. Y is the square root of 3 over 2. And we can very easily get sine and cosine and all the other trig ratios from that piece of information. So this is just a very nice graphical organizer to help us with special right triangles and evaluating those trig ratios. Here's what it looks like to lay a 30, 60, 90. Here you have an x value of square root of 3 over 2 and a y value of 1/2. Here's the 45, 45, 90. If you recall, those two legs were both square root of 2 over 2. So in this case, our x coordinate and our y coordinate are the same value. And again, 60-degree angle with the 60, 30, 90, which I just drew a couple of moments ago. So from that, what we get are these. I'm going to just highlight these right here. We get these points in the first quadrant. But if you recall, all of these other angles have the same reference angle. So they're all going to be the same coordinate points, except in the different quadrants, you're going to have positives and negatives, whereas everything in the first quadrant is positive. So here, you're going to have positive, positive. Here, you're going to have negative, positive. So all of our x values will be negative. Here, here, here. In the third quadrant, you're going to have negative, negative. So all of our coordinate pairs are going to be negative. And here you're going to have positive, negative. So our y values will be negative. Now the interesting part about this, what comes from the unit circle, if you think about sine being opposite over hypotenuse, this is our theta, then this is our opposite side, or y. And our hypotenuse is 1. So our side values are just our y coordinates. We can pull those right off the unit circle. Similarly, for cosine, cosine is adjacent over hypotenuse. Here's our adjacent side on the x side. So adjacent is x, and hypotenuse is 1. X over 1 is just x. So these are our x coordinates. Just abbreviate that. And you can get the other trig ratios just as we've been doing, taking the reciprocal and taking the quotient. So if we look at the unit circle and look at the 0, 90, 180, 270, otherwise known as the quadrantals, we can fill out sine and cosine of various angles. So for example, let's remind ourselves that sine is y, cosine is x. So let's just take 0 degrees. 0 degrees, our x is 1, so co is 1, and sine of 0 is the y, or 0. Up at 30, cosine is the x, and sine is the y. At 45, cosine and sine are both square root of 2 over 2. At 60, our cosine is our x again, our sine is our y, and at 90, our cosine is our x, and our sine is y. And we can continue to do this for all of the angles along the unit circle. We could even extend this table and start figuring out what the tangent values are, and so forth.